Please cooperate. Good evening, students. Today our class is paper 7, unit 9, paper 7, unit 9. That is biosynthetic methods and general methods and feeding experiments. Biosynthetic methods, general methods and feeding experiments. So we are going to next discussing biosynthesis of natural products. Biosynthesis of natural products is that, okay. So generally biosynthesis of natural products, when we are going to biosynthesis of natural products. Okay, in general, before going to natural products, okay, the compounds which are obtained from living organism, the compounds which are obtained from living organism are classified into two types. One is primary metabolites and secondary metabolites. One is primary metabolites and secondary metabolites. Primary metabolites and secondary metabolites. So primary metabolites are important for life process. These are essential for life process. These are may or may not essential for life process. These are distributed in each and every cell. These are may or may not distributed in each and every cell. They are complex structure. They're complex structure and high molecular weight compounds. High molecular weight compounds. So these are simple structure and low molecular weight compounds. Examples for primary metabolites is RNA, DNA, and etc. Amino acids, etc. So protein. Next, secondary metabolites examples are natural products. Secondary metabolites examples are natural products. Okay, simply that means that by the compounds which are obtained from living organism, that secondary metabolites. The secondary metabolites are obtained from living organisms are classified as natural products. Okay, so natural products. Biosynthesis of natural products means biosynthesis of when we take 6 moles of carbon dioxide, when reacting it 6 moles of water molecule, then the product is in presence of chlorophyll, and sunlight, in presence of chlorophyll, sunlight. The carbohydrates are the product. Glucose is the product, and byproduct is oxygen is the byproduct. This is the biosynthesis of natural products. Okay. Difference between laboratory synthesis and biosynthesis. Difference between laboratory synthesis and biosynthesis. Okay, difference between laboratory synthesis, very important. Difference between laboratory synthesis and biosynthesis. Difference between laboratory synthesis and biosynthesis. Okay, for first laboratory synthesis, these are slow reactions. Laboratory synthesis occurs in presence of strong base or strong acids are required. They require strong acids and strong base are required. For laboratory synthesis, strong base and strong acids are required. For laboratory synthesis, employs strong oxidizing agents like so in presence of the strong oxidizing agents. Require strong oxidizing agents like KMNO4, K2CO3, and strong reducing agents. Agents like LH and NaBH4, LH and lithium hydride example. And most of the laboratory synthesis are carried out in acidic or basic pH condition. Quite a majority of the organic synthesis are catalyzed by chemical catalysts like AlCl3, FeCl3, zinc chloride. So when we going to here, these are fast reactions. So all the reactions are occurred in water medium. The reactions are occurred in water medium, and the enzymes. These reactions are catalyzed by enzymes. These reactions are catalyzed by enzymes, and at body pH. Reactions are monitored at body pH. Reactions are monitored at body pH. So these are the difference between major difference between laboratory synthesis and biosynthesis. This is a very important difference between laboratory synthesis and biosynthesis. This is a very important. Next, we are discussing coenzyme. Next one is coenzyme. Coenzymes. That is NADPH, NAD or NADPH or NADP replace, that is oxidized from the nicotinamide adenine dinucleotide, that is catalyzed oxidation reaction. So that is structure of NAD is structure of NAD plus is NH2. OH NH2. This is NAD, nicodinamide adenine dinucleotide. Nicotinamide adenine dinucleotide. Nicotinamide adenine dinucleotide is one of the coenzyme. This coenzyme is NADPH is oxidized from nicotinamide adenine nucleotide. It is catalyzed oxidizing reaction. Next one is ATP, adenosine triphosphate, ATP. It is an important coenzyme which is involved in the transphosphorylation reaction and also act as an enzyme reservoir. So it is an important coenzyme which is involved in the transphosphorylation reaction, and it also acts as an enzyme reservoir. Okay, ATP structure. The structure of ATP is adenosine triphosphate. 3 phosphate rings are there. Adenosine triphosphate. So it is involved in the phosphorylation. It is a transphosphorylation and act as a reservoir. It does act as enzyme reservoir. So mechanism for this reaction is when we take any hydroxy group. If you take any hydroxy group, I am taking this hydroxy group here. This hydroxy group, when reacting with your phosphorylation, the bond is shifting here, then forms OP. So this is a P is the phosphorylate moiety, P is the phosphorylate moiety. So next, third one is SAM, S-adenosine methionine, S-adenosine methionine. This coenzyme is capable of transforming methyl group to oxygen, nitrogen, and carbon atom. It is a coenzyme capable of transforming of methyl group to oxygen, nitrogen, carbon atoms. The structure of SAM is methyl NH2 COH. This is the adenosine methionine. Adenosine moiety, adenine moiety, and methionine. Methionine moiety. Okay, this is a SAM. Next one is ATPP or TPP or TPP plus. TPP or TPP plus. This is thymine pyrophosphate. Thymine pyrophosphate. It is a coenzyme involved in decarboxylation reaction. TPP is a thymine pyrophosphate. It is a coenzyme which involves in a decarboxylation reaction. It is involved in decarboxylation reaction. In H2, the structure of TPP, thymine pyrophosphate structure is this is the thymine pyrophosphate. This is thymine pyrophosphate. So these are the some coenzymes ATP and SAM and TPP and NAD. These are some coenzymes. That is but whatever that the differences between laboratory synthesis and biosynthesis are very important. Next, methods for determination of biosynthetic mechanism. Methods for this is very important. Determination of methods for determination of biosynthetic mechanism. Methods for determination of biosynthetic mechanism. So one is by isotopic labeling methods. One is by isotopic labeling method. by isotopic labeling method. So in this isotopic labeling method, so we are using simply in generally in organic chemistry that organic compounds are composed with carbon, hydrogens, oxygen, sulfurs, nitrogen atoms are there. So in generally we are taken for normal isotopes, we are taken heavier isotopes, heavier isotopes, that is for carbon C13, for hydrogen deuterium or tritium, for oxygen C18, C16, and sulfur nitrogen is a different oxygen 18, and the phosphorus 35, and the nitrogen 15 isotopes are used, and based on this using we can identify the biosynthetic mechanism. So that is important. Next one is identification of this. Next one is identification of position of labels in labeled natural products. Identification of the position of labels in the labeled natural product. So this is a very important identification of the position of labels in the labeled natural products. So one is chemical degradation. Two methods are there: chemical degradation method and spectral method. First, we are going to discuss chemical degradation method. Chemical degradation method. In this chemical degradation method, so I am taking one of the compound, quinine. This is a quinine. In this quinine, whatever that we are labeled the carbons, labeled carbons are C13 carbon atoms. Normal carbon atoms are C12 carbon atoms. So these are dotted, the thick dotted carbon atoms are C13 carbons, and normal are the C12 carbon atoms. So we have to identify the position by using chemical degradation in the compound. Okay, when we are going to Kuhn-Ruth oxidation. When undergo Kuhn-Ruth oxidation, we are getting acetic acid. We are getting acetic acid. So this acetic acid, in this acetic acid, the carboxylic acid carbon is the C13 carbon. They undergo Schmid reaction. Schmid reaction, we are obtain ethylamine and carbon dioxide. Ethylamine, this is ethylamine and carbon dioxide. Carbon dioxide is normal. And another method is undergo Hoffman exhaustomethylation method. Hoffman exhaustomethylation method, simpler Hoffman degradation. First, this tertiary nitrogen undergo converted to quaternary nitrogen. Quaternary nitrogen. In this quaternary nitrogen undergo Hoffman degradation is Hoffman degradation. And second way is and third way is So these are the products are obtained in the Hoffman degradation reactions. These are products. So when I'm taking one compound, I undergo again degradations. This is the compound I'm taking, undergo further degradations. When this compound undergo first hydrolysis, hydroxylation, 1,2 hydroxylation. When reacting with excess methyl iodide, then heating with silver oxide heating, then the product is 1,2-dihydroxy compound. So when this is positive charge, when this compound undergo oxidation, when this compound undergo oxidation, so cleavage takes place, then forms the cleavage like this, then forms CHO, CH3 plus formaldehyde. This is that. This is formaldehyde, this carbon. When this formaldehyde undergo oxidation, further oxidation, then forms carbon dioxide. Okay. When this is undergo further Hoffman degradation, further Hoffman degradation, then the product is plus okay, when it is undergo, this is undergo KMnO for oxidation. KMnO for oxidation, the bond cleavage takes place here, then forms plus it is undergo again further oxidation, they forms carbon dioxide. So like this. So when it is undergo further cleavage with KMnO4, so bond cleavage here takes place, then forms COH plus CH3. When it is undergo further Schmidt reaction, then carboxylic acid converted to amine. When this compound again undergo excess methyl iodide, silver oxide heating. Third one is Hoffman exastomethylation method. Then forms a double bond. In this double bond undergo KMnO4 oxidation. Acetic acid plus formic acid. Acetic acid and formic acid. When it is undergo further oxidation, then water molecule and carbon dioxide. So these are the products of the pharmaceuticals. So this is the chemical degradation method and a spectral method. For spectral method, by using mass spectra, UV, IR, proton NMR, we can determine the Position of labeled isotopes in natural products. Labeled isotopes in natural products. So best example I am given here. One example. This is O-succinyl benzoic acid. This is O-succinyl benzoic acid. And this O-succinyl benzoic acid, when reacting, feeding into Rotacina plant, then forms CH3. Okay, so here numbering I am given here. One is a compound. This name is Shini is the name. So when we recorded for this spectrum based on the C13 NMR, we can based on the C13 NMR, we can easily find out the position of labeled isotope in the labeled natural product. Next, feeding experiments. Feeding experiments. So this is very, very important. Feeding experiments are very, very important. Feeding experiments means we are introducing the isotopically labeled natural products into plants. We are introducing labeled isotopically labeled natural products into plants. So different feeding experiments are there. One is atmospheric feeding. One is atmospheric feeding. One is atmospheric feeding. Simply in this atmospheric feeding, a plant is placed in a closed vessel area. Closed area. The plant is placed in a closed area. The plant is placed in closed area. The plant is grown in this closed area. When this we are introducing labeled carbon dioxide. We are introducing labeled carbon dioxide, labeled water molecules, labeled carbon dioxide, labeled water molecules. Then they observed this plant, this labeled precursor, and these labeled precursors are introducing the plant body. Okay, this is atmospheric feeding. Okay, in this atmospheric feeding, so whatever that the plant is grown in closed vessel area, and we are introducing our labeled isotopical labeled carbon dioxide and water molecules. These are observed by plant and placed in different places, and this is the atmospheric feeding experiment. Next one is hydrophonic method. Next one is hydrophonic method. In this hydrophonic method, so here one plant here, one so in this hydrophonic method, we are introducing whatever that labeled precursors. The starting materials are used in the natural products is called as precursors. The labeled precursors are placed in the roots of the plant, placed in the roots of the plant. Whatever we take in water molecules and whatever we take in copper sulfate and zinc sulfate, magnesium, manganese chloride, potassium nitrate, and ferrous sulfate and boric acid and molybdenum oxide. These are the different isotopically labeled natural products are placed in at the roots of the plant. At the roots of the plants. These roots are observed that labeled precursors into the body of the plant, and the body observed that labeled natural products and labeled precursors and placed in the different parts in the body of the plant. This is the hydroponic method. Third one is wick method. Wick method. Okay. So in this wick method, so stem, we are assuming this is a stem of the plant. 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 Threading the, in wick method, threading the plant. Threading the plant with the needle and thread. Threading the plant with the needle and cotton thread. This is a thread. Threading the plant with the needle and cotton thread. Okay. This thread, cotton thread are placed in the beaker contains, placed in the beaker containing nutrients solution and labeled precursors molecules. Okay, that thread are placed in the beaker containing nutrient solution and labeled precursor molecules. These labeled precursor molecules and nutrients are travel through the cotton thread into the body of the plant, and these nutrient solutions and labeled molecules are placed in the body by using wick thread. Therefore, this is called wick method. And third one is direct injection method. Direct injection method. So in this case, so whatever that one plant here, to this plant we are inject the syringe. Okay, in this method, in direct injection method, we can introducing the nutrient solution and labeled precursor molecules through the syringe. We are inject the this labeled precursor molecules into the plant stem or leaves by using syringe. Okay, this is direct injection method. And painting method. Or spraying method. Painting method or spraying method. So whatever that net nutrient solution and labeled precursor molecules we are introducing in the plant, that solution is spraying on the leaves of the plant. Therefore, these leaves observe that labeled precursor molecules and nutrients from the solution placed in the body part. Okay, this is a painting method. This is a very important. Feeding experiment is very important. Okay. Next one is, last one is very important. This is also, so measurement of incorporation. Measurement of incorporation. So first one is absolute incorporation. Absolute incorporation. That is, absolute incorporation is equal to total activity of the isolated natural product by total activity of the administered labeled precursors. This is a absolute incorporation. We are going to a specific incorporation. In this specific incorporation, specific activity of the labeled isolated natural product by specific activity of administered labeled precursor. Okay, this is the absolute incorporation, specific incorporation. This is also very important. So in this unit, in this 9th unit, so important topics are, so differences between laboratory synthesis and biosynthesis are very important, and methods for determination of biosynthetic mechanism, and identification of position of labels in labeled natural products. One is chemical method and spectral method, and feeding experiment methods, and measurement of incorporation. These all the topics are very important. I think this complete unit is very important. Okay, tomorrow we are going to discuss another unit. Thank you.